Okay, today we're going to look at finding the area of a triangle, and we're going to look at right triangles and non-right triangles. So the notes for 6.1 and 6.2. So first we're looking at the area of right triangles. So remember what that means is the triangle has the right triangle, so it also has the hypotenuse. So we can use Pythagorean theorem. Pythagorean theorem, if we need sides, and we will. So remember that's a squared plus b squared equals c squared. And we're going to use the formula for the area of a right triangle, which many of you should remember, is a equals 1/2 base times height. So again, this goes back to geometry and even prior to that, finding the area of a triangle. So in example 1, we're given a base of 5, a height of 12, so we can just plug it into our formula, and we get area equals 1/2 base of 5, height of 12, equals 1/2 of 60, equals 30. So again, that's just the basic area of a triangle. If we look at example 2, it's still a right triangle, but we're not given the base. We're given the height and the hypotenuse. So in this example, we can label the base A. We'll label this height B, and again, the hypotenuse always has to be C. So we need to solve for A before we can find area. So if we say A squared plus 2 squared equals 4 squared, we get A plus 4 equals 16. Sorry, A squared plus 4 equals 16. So A squared equals 12. So A equals radical 12. So if we let A equal radical 12, then we can fill out our formula for area equals 1/2 base, which is radical 12, times height, which is 2. And actually, looking at this equation, the 1/2 and the 2 cancel out, and we actually get area equals radical 12. If we put that on our calculator, we get radical 12 is actually 3.46. So that would be our answer, our area. So again, area of a right triangle, area equals 1/2 base times height. Now, if we go to the next slide, looking at area of oblique triangles. So again, oblique just means non-right. So these triangles do not have a right angle, so we cannot use Pythagorean theorem. And this is the formula, or the set of formulas we're going to use. And to use this formula, you have to have the information pertaining to the triangle of side, angle, side. So you have to have, again, a side, the angle right next to it, and the side right next to that in order to use this formula. So first let's look at some basic examples. And again, the area is just 1/2 the two sides times the sine of the included area, or the included angle. So let's take a look at these. So again, first we're going to draw our triangle to see what we're given. A, B, C. We're given little a is 8, little b is 6, angle C is 30. So you can see right here that we have side, angle, side, all right in a row, and all lined up. So we can use our side, angle, side formulas. So to decide which formula to use, we can look at which angle we have, and we have angle C. So if you look up at the formula, if you want to use the formula that calls for the sine of C, so we're going to use this formula. So it is area equals 1/2 side A, which is 8, side B, which is 6, sine of 30. So if we plug that into our calculator, so 1/2 times 8 times 6 sine of 30 and equals 12. So the area of this triangle is 12. Now, again, as I said, to use these formulas, you have to have side angle side information. Sometimes you won't always have side angle side information, so you may have to use the law of sines to find that set. So, for example, if I look at this triangle, I'm going to set up my information. So A is 35 degrees. B, angle B is 15 degrees. And little c is 5. So if I look at the information I have, I do not have side angle side. I actually have angle side angle. So to find side angle side, I need another side, right? So what I'm going to choose to find is I really need side B. I could choose A if I wanted to, but I'm going to go ahead and try to find side B. That way I would have side angle side. So to find side B, I'm going to use the law of sines and to fill in the missing information. So looking at this, I need to find side B. I have angle B, so I really just need to find angle C so I could have a full set of information to use law of sines. So first I'm going to say 180 minus 35, angle A, minus 15, angle B. And if I put that on my calculator, I get 130. So angle C is 130. So now I have a full set of information on angle C that I can use law of sines to find little b. So over here I'm going to say sine of 130 over 5 equals sine of 15 over b. And I cross multiply, so I get b, sorry about that. So I get b sine of 130 equals 5 sine of 15. Shoot, sorry guys. Sine of 15. I divide through by sine of 130. And on my calculator, I know you guys can't see this, but I'm typing in 5 sine of 15 divided by sine of 130. And I get little b equals 1.69. So I have little b equals 1.69. So I did all of that to again fill out my side angle side information. So now I have side of 5, angle of 35, side of 169. So I can again go back to my formula and use the formula that uses angle A, and it is 1/2 BC sine of A. So to compute the area, I can say area equals 1/2 1.69 times 5 times sine of 35. And I can plug that into my calculator. 0.5 times 1.69 times 5 times sine of 35. And I get that my area is 2.42. So the next triangle is similar to this, and it has, it also you have to use some calculations to find side angle side. So I want you guys to pause this video and try it on your own in your notes and come up with the area. And I'm going to fill it out without talking through it. So, so pause it now and see if you can complete it. Okay, so in completing the next one, I went ahead and set up the triangle. I found I don't have enough information. I don't have side angle side, so I went ahead and found the missing angle, and I found it to be 80. So now, to complete the side angle side information, I am going to use, or I want to use, side C, angle B, and side A. So I need side C. So I'm going to use law of sines to find side C. So I'm going to set up sine A, because I have complete information. So sine of 40 over 4 equals sine of 80, because I need side C, over C. So if I cross multiply, C sine of 40 equals 4 sine of 80. Divide through by sine of 40. And plug into my calculator, 4 sine of 80 divided by sine of 40. And I get that little c equals 6.12. So c equals 6.12. So now I have side angle side. I want to use the formula that requires angle B. So that formula is area equals 1/2 side A, which is 4, side C, which is 6.12, sine of B, which is 60. Plug that into my calculator, 0.5 times 4 times 6.12 times sine of 60. And I get area equals 10.6. Okay, so that is sine of oblique triangles when you're given various combinations of angles and sides. You want to get it, you want to complete the triangle using law of sines to where you have side angle side information to use the formula. Okay, the last combination or set of formulas we're going to look at is very straightforward and very easy to use. It is the only formula you use when you're given 3 sides, and you can only use it when you're given 3 sides. So to use this formula with your 3 sides, you don't have to do any work beforehand because you're given the 3 sides. So first you have to find, though, this variable called s, and s is just 1/2 times the sum of the 3 sides. Then you plug in that s value into your actual area formula underneath the radical. So again, this formula is very straightforward. Let's just run through a couple examples. So for example, this, and we don't really even have to draw the triangle for this because the formula is pretty straightforward. So first we just need to find s. We're given our 3 sides. So s is equal to 1/2 the sum of those. So 1/2 times 4 plus 5 plus 7. And actually, this one we can do by hand because this becomes 1/2 times 16, and 1/2 times 16 is 8. So our s is 8. So we're not finished yet, but we found that one of the values that we need for our area formula. So to plug that in to our area formula, we say area equals square root of s, which is 8, times s minus a, so 8 minus 4, times s minus b, times s minus c. So we could plug that into our calculator, just like we see it, or we could really do this one by hand. We keep this 8. 8 minus 4 is 4. 8 minus 5 is 3. 8 minus 7 is 1. So this becomes the square root of 8 times 12, which is 96. And then the square root of that is 9.79, or actually we'll go with 9.8. So the area of this triangle Again, by finding S first and plugging that in is 9.8. Now we can run through the last example. Oops, sorry about that. So again, given this side, side, side triangle, we first find S, which is again 1/2 times the sum of our sides. And if we plug that into our calculator, we get 11.5 is our S. So again, now we use that S in our area formula, which is area equals the square root of 11.5 times 11.5 minus A times 11.5 minus B times 11.5 minus C. Now, on this type of equation, you can plug that in all together on your calculator, and I can show you when we get back to class next week if you want to. But otherwise, just pull up your radical sign and plug it in exactly how you see it with on the screen, parentheses and all. And when you plug it in to calculator, you should get area equals 19.8. Okay? So again, so that is just a run through of all the possible area formulas we're going to cover. And that is plenty enough practice for you to do the homework that was assigned in the book, page 441 and I think page 435. I don't have that right in front of me. But anyway, go through those problems using these formulas, and we will check them next week. All we have left now is we will review on Monday and test on Wednesday for chapter 6. And I will see you then. Thank you.